From Ultima's doorstep, live at the Johns Hopkins Applied Physics Laboratory in Laurel, Maryland, we're checking back in with the New Horizons team. We've asked you for your questions, and we're going to talk those questions over with New Horizons Principal Investigator Alan Stern, Mission Operations Manager Alice Bowman, and Science Team Co-Investigator Kelsi Singer. In fact, we're going to jump right into this with Mission Principal Investigator Alan Stern from the Southwest Research Institute, Boulder, Colorado.
Hey, Mike.
Alan, I guess welcome first, right? And thanks. After 13 years, 4 billion miles, we are literally on Ultima's doorstep. Kelsi and Alice will talk about what's happening with the spacecraft operations and the science teams, but a general sense, what's it like on the team being this close to the flyby?
You know, Mike, it's electric. I think across the whole team, people are ready. They're in the game. We can't wait to go exploring. We had such a spectacular success at Pluto. It's been 3.5 years. We've worked so hard. People are ready to see that pay off and to see what we can learn about the birth of our solar system.
Can you give us an idea what that journey was like? You know, I mean,
from Pluto
the
to
expanse
Ultima?
of the solar system. I even start like from Earth to Pluto and then now beyond to Ultima. Just a sense of what that journey was like, making the expanse of the solar system.
Well, you know, very few teams have had this experience and this privilege of crossing the entirety of our solar system on a mission. And really only the pioneers and the Voyager teams that came before us. For us, because we're so much smaller, about 10 times fewer people working on New Horizons than worked on Voyager, we were busy the entire time. Every single year with planning for the flyby, with navigating the spacecraft, taking care of the spacecraft, getting all of our tools in place for the flyby, training the team. And it's been the same way on the journey 1 billion miles past Pluto now to Ultima. Yeah. 3.5 years, 52 weeks a year of work to get ready for this one-shot flyby that's going to take place Monday and Tuesday.
I guess in anticipation too, right? The team is arriving here at APL. Scientists are getting in place. Walk us through from that team perspective, what's happening over the next few days?
Yeah, well, what people probably don't realize is the big New Horizons team, the overall New Horizon team consists of various sub-teams. There's a navigation team, there's a spacecraft mission operations team, a spacecraft engineering team, there's an instrument team for the payload, and there's a science team, and of course your public affairs team.
Right, yeah.
And so all those threads are taking place at the same time. The navigation team is still working with images coming back to find out how close we are to on course, how close we are to our arrival time, and to potentially send commands to the spacecraft just to tweak things.
Yeah.
And at the same time, mission control is downloading data from the spacecraft and sending up various maintenance and other activities to supplement the onboard stored commands. And then the science team, which just got in place today, is in a science team meeting, reviewing their tools and getting ready for the waterfall when data starts to come.
Start happening. We have some animation that shows what we anticipate the flyby, right? I mean, the cool thing about this is we just have no idea, but we're taking our best guesses, right, of what we think it might look like.
Let's have a look.
See if we can show where the spacecraft as it approaches Ultima and then would fly over. So we see just the approach. This is a much smaller object than Pluto, and I think we try to make people aware of that,
right?
And the differences between this flyby and what New Horizons did at Pluto.
Right, and this is an artist's animation, because you couldn't fit it all onto scale. In reality, we're flying by at 3,500 kilometers away. That's the distance from LA to DC, and Ultima is about the size of Greater Washington DC. As seen from the spacecraft, it's going to get about as big in the cameras as a full moon would be on Earth. But we've got telescopes, so if you've ever looked at the moon through a telescope, you can imagine the kind of views from onboard New Horizons that those cameras will see studying Ultima as we flash by at 32,000 miles per hour.
Yeah, and we'll see it. And Alice and Kelsi will talk about specifically what we're looking for when we go through spacecraft operations and science. And we'll always point folks to the the New Horizons website. It's pluto.jhuapl.edu, where we'll be putting pictures from the flyby. So you're going to be able to see as Ultima has grown from a dot, almost before a dot, to a real world. Over the next week, we'll be able to see this. So thanks, Alan, and we're going to bring you back for questions later on in the program.
Sounds great.
The New Horizons story is one of perseverance, persistence, education, creativity, inspiration. Folks who have followed this mission since the beginning have seen these stories come through in documentaries like Passport to Pluto and The Year of Pluto. Well, now there's another installment coming up, Summiting the Solar System, that'll be available soon on the mission website. We can take a quick look at that right now. Now, someone who figures prominently in that documentary is Alice Bowman, the Mission Operations Manager from the Johns Hopkins Applied Physics Laboratory. And Alice, great to have you here. Thank you.
Thank you.
We've done our previous shows from your neighborhood. We were in Mission Operations, right in the heart of all the activity, but things are getting pretty busy there right now. So we've come over here. First, maybe tell us just where is New Horizons and what's been happening on board the spacecraft?
Sure. We are 4.1 billion miles from Earth. That's 6.6 billion kilometers. And currently we are downlinking the data from our optical navigation measurements, as Alan had mentioned. And then that data goes over to the navigation, mission design, science operations teams. They process that and are looking to see if we are on course or not. Over the past previous days, what we have been doing is loading that core sequence, the 9-day flyby set of commands to the spacecraft. We accomplished that December 20th. On the 24th, we confirmed that the spacecraft was in the right configuration to transition into this 9-day flyby set of commands.
And there was some celebration on the team with that. I noticed seeing that announcement too. That
Yes,
was ready to go.
That was a big milestone. On the 26th, we confirmed that we had entered encounter mode, which is wonderful because we have a certain set of autonomy that is now active in that mode. And we are continuing, obviously, to get data down from the spacecraft. On the 29th, we'll get our final optical navigation measurement down. The teams will be processing and looking at that. On December 30th, we have our first opportunity to update uplink a knowledge update, which would be a time offset, perhaps, of the observation sequence. We have our failsafe A and failsafe B data coming down on the 31st, along with 6 uplinks to the REX instrument on board the spacecraft.
Okay, and the failsafe, that's the data you want to bring down before the encounter, just in case something happens with the spacecraft.
Yes. January 1st, we have the phone home, which currently is at 10:29 a.m. Eastern time.
Right, important to track that, right.
Important, and that time will be adjusted by whatever we put up to the spacecraft, whatever knowledge update we put up.
I'm glad you brought that up, because I think that's important for people that are watching to notice that, because that's the call from people, that's the call from the spacecraft that says, I'm okay, I've got the data. That's an important call home.
It's an extremely important call. We have 15 minutes for that phone home. We call it the phone home. And we won't be getting any image data down or any science data down. We'll be just getting engineering, health and safety of the spacecraft. We'll be able to see how much data was recorded on the recorders. And so it'll be a good assessment how the spacecraft is doing. And then later on that day, we have the data sets coming down from the spacecraft.
These are the what we anticipate would be the close-ups and the bigger ones, right?
Wow,
the ones that we're looking forward to seeing. This is where we reveal the world for the first time. Exactly as it is up close. You mentioned encounter mode. How important that was. It's not just the spacecraft doing one thing and then moves on to another. Encounter mode is pretty important. So maybe explain why what New Horizons is doing when it's in encounter mode and why it's important.
I'm sure. Just real quick, the encounter mode will. Because this is a flyby mission, we only get one chance to get it right. We can't go back, do it again. So we have this special mode that we put the spacecraft in, and what that does, it protects all the science observations. So if we have any kind of abnormal condition on the spacecraft, the autonomy system will try to fix it as best it can, and then it will pick up with the next measurement on the spacecraft, and we'll continue taking data of the system.
I mean, that's important. It cannot call home.
No.
You don't have time. Because this lays one of the questions that we have from social media too is, how long does it take to communicate with a spacecraft that's 4 billion miles away?
Yeah, it's 6 hours, 8 minutes for us to get a command to the spacecraft.
And then you'd have to turn that around to even hear that whatever you sent to the spacecraft took.
Exactly. So we call that a round trip light time, which is about 12 hours and 15 minutes.
Okay. Mention the questions that we're taking from social media. We are using 2 hashtags. You can use the Ask NASA, and you can also use Ask New Horizons. So keep your questions coming. We are doing another Q&A session at the end of the program that we'll get to, and of course, we will always keep the lines open to answer questions beyond this program. So Alice, we talked about timing. We mentioned we can't do any more propulsive maneuvers, what we were calling course corrections, but we do a timing adjustment.
Right.
A little bit about the timing adjustment, what that would really do on board the spacecraft.
So it's like applying a delta to the timing of the measurements, and so we can adjust either to make those observations occur a little bit earlier or a little bit later. And of course, when we do that, we'll have to update some of the pointing information on board the spacecraft as well. So there's a couple of components that are hooked together for that adjustment.
Okay.
And that's, we want to get the best observations at the best time. And so we call that the aim point. That's the 3,500 kilometer, 2,200 mile point. And we want to arrive there at 05:33 GMT or 12:33 a.m. Eastern Time, January 1st. And if we see that we're coming in a little bit different from that, that's when we would do that knowledge update or that time and pointing adjust.
That was adjustment. I think you talk about the precision required for something like this. I mean, there's a bit of an error, but I can tell you from the Pluto experience that the navigation team, the operations teams, don't really want to rely on that margin. They want to get it as close to that aim point as possible. And I think at Pluto, it was after 3 billion miles, it was maybe 80 miles with it, or it was something.
88 seconds early and 26 miles off the aim point.
So I mean, we're talking about after 4 billion miles and 30, we're still talking about amazing precision.
Yeah, but this object is so much smaller. We really need to get, much, much closer than that.
So that margin of error is much smaller than it was before. All right, well, thanks, Alice, and we'll bring you back later on too for some other questions. But I'll point out that when Alice is talking about distance, you really get to appreciate the distance of the Ultima Thule is 1 billion miles beyond Pluto. And if you look back at how New Horizons traveled from Earth to Pluto, again, you get a real good sense of the journey that this spacecraft is taking across the solar system.
Pluto explored. How far, how fast? NASA's New Horizons mission launched in 2006 for the first ever close-up study of Pluto and its moons, which it flew by in July 2015. To get there, it had to be small, light, and very fast. Pluto is far away, about 3 billion miles from Earth. That's a long way to ride your bike. Pedaling to Pluto would take 47,600 years. Driving wouldn't be much better. Los Angeles is about 2,500 miles from New York. You think that's far? Driving to Pluto is more than 500,000 times there and back. And a road trip to Pluto would take more than 6,000 years. But New Horizons is fast. Zipping along at 3,400 miles per hour. It got to Pluto in just 9.5 years. That's far, but that's also fast. That's Pluto explored. How far, how fast?
Okay, so now we'll turn our attention from spacecraft operations to science operations. And with Kelsi Singer, she's a New Horizons co-investigator from Southwest Research Institute in Boulder, and a key member of the team mapping out the science operations, the observations that New Horizons is making at Ultima Thule. So Kelsi, welcome.
Thank you.
Thanks for being here. Alice mentioned that the core load, the core encounter load, is running on the spacecraft right now on its computers. So I guess it sounds like, obviously, it's already collecting data. What sort of stuff is New Horizons collecting now?
Yeah, so the spacecraft is performing a couple of really important functions right now. One of them is, as Alice was explaining, we don't know exactly where Ultima Thule is.
Mm-hmm.
So we're taking observations with our black and white camera that has a really big zoom lens on it, and we're trying to pinpoint right where it is so we can get those high resolution images that Alice mentioned.
Yeah.
We're also trying to see if there's more than one object in the system. And we're approaching an important milestone, and that is that today or tomorrow, Ultima Thule itself will be more than 1 pixel across.
Okay.
And we're flying so fast that between now and the close approach on New Year's Eve, Ultima will go from about 1 pixel to 1,000 or so pixels across.
But I mean, even between, okay, that's a huge jump. And like we've always, we've said in, in previous shows and other discussions, this is a fast flyby.
For sure.
Before we know it, that dot, and we're going to be on top of it, and then we're past it. It's gone. But you can tell a lot about the object. We knew from 1 pixel we could tell some things, but you can tell some things, whether it's 5 pixels or 20 or something else. Too.
Yeah, so we'll start to see what the actual shape of the object is. And then we will eventually get the very highest resolution images.
Mm-hmm.
So about 1 day out, we'll turn on all of our instruments and we'll be taking different kinds of observations. We'll take black and white pictures, we'll take color pictures, we'll take compositional information. And we don't know exactly how fast the object is spinning, and we don't know which way its spin pole is pointed either. So we have observations at different time intervals to try and catch as much of the object as we can. So we'll be doing that about 1 day out, and then 1 hour out is when our highest resolutions images will happen.
Okay, so we'll get into that timeline too. You mentioned even just the shape, or the one of the bigger mysteries that was happening right over the past couple of weeks was the lack of what we call that light curve, right? The light reflecting off the object as it rotates. That I know that, so you already have a mystery we want to solve as the spacecraft goes past it.
Yeah, so normally you would expect to see variations in brightness as the object is turning and you see different sides of it. But so far, we actually haven't seen any strong variations in brightness, and we're all not sure why. We would expect to see those.
You mentioned the timeline, the intensity of the timeline that had been happening before, right? So we have, there's a program called Eyes on the Solar System, which we used during the Pluto flyby, and it was an awesome simulation, especially when we weren't in contact with New Horizons, to be able to show what the spacecraft was doing. That will be available again for the Ultima flyby, and what those graphics will tell you, and in real time, if you follow it online, is what each instrument is doing and where the spacecraft is in relation to Ultima. So let's go through the most intense periods, right? There's a 24-hour period that you've mentioned that where there's activity, and then there's a real intense hour-long period. What's the spacecraft doing when that's happening?
Yeah, so during the hour before closest approach, we'll start taking higher resolution images with the LORRI camera. Mm-hmm. We'll also be doing scans with our color instrument and our compositional instrument. We'll also be searching for any kinds of gas or dust around Ultima. And so all of these things happen in a very short period of time.
Okay. Some questions from social media that I'll throw one out to you now before we bring everybody else back and then throw it around there too. But did we have any hints yet of like what's the chemical composition, for example, on Ultima? Do we have any hints of kind of what it's made of? I mean, besides what it looks like?
Yeah, so we don't have a lot of information on the composition. That's one of the things that we're really excited to learn. We know that it's relatively dark, and this is typical of objects like Ultima Thule in that part of the solar system, the distant outer solar system. And we also know that it's got a little bit of a red tint to it. And this is also typical of objects, and we don't know what creates that. And so going to Ultima Thule will give us kind of the first real information, and then we can apply that same information to all these other objects that have a similar darkness and color.
There's a great question here that's kind of reminding me to pull this up another level and say, just what kind of an object is a Kuiper Belt object? I will see on social media some people will reference an asteroid or a comet or something like that. What is a Kuiper Belt object?
Great question. So the Kuiper Belt objects are objects that formed in this outer part of the solar system. They're probably pretty icy. They might have some rock in them too, but they mostly formed in this outer part of the solar system early on in solar system history, and we think they've mostly been sitting there in deep freeze out there.
Yeah.
And so we are really excited to see this type of object because it may be a piece of the early solar system that we can study. And you can't get that same kind of information from inner solar system objects.
So I believe, and we've heard it talked about on the team too, aside from being the farthest object explored, we could be looking at the most primitive or some of the oldest pristine material.
We think it could quite likely be very primordial object.
Okay. Well, Kelsi, thanks for this part. And then so hang here. But before we get to the larger Q&A segment, you know, we're getting well wishes from across the space community and the public that we're seeing on social media, and some other folks have made some videos for us to wish New Horizons well on its journey past Ultima.
Say, gang, where's that New Horizons spacecraft passing on January 1st?
2014 MU-69, Ultima Thule.
Planetary Society can't wait to see those pictures.
Good luck, New Horizons.
New Horizons, hi, Commander Chris Hadfield here. You are the steely-eyed, high-speed, fleet-footed messenger way out beyond the edge of what we barely understand. Safe travels and happy prospecting as you look at Ultima Thule on the way by, and Happy New Year.
Okay, so now we're back with the entire group. So Alan, Alice, and Kelsi have joined us again. And now for the remainder of the program, we're going to take your questions. We have a long list of questions that have come in from social, even from the last event that we had, and that we've been asking for them online with the hashtags AskNASA and AskNewHorizons. So we'll try to get to as many as we can here with the remaining time that we have. But as always, we are going to keep the lines open, and we will answer them on Twitter. We will answer them online and on web, and through the programs that we will have through the remainder of the flyby. I'm going to go with the obvious one first, because this is something that people just always want to know with this is we've had hints of what Ultima might look like, what it might be doing, how it spins. What do you think, right? What are you anticipating? What do you think Ultima will look like when you get there?
I can answer.
I will go through each of you can answer that question.
That is such a hard question.
Yeah.
And I wish I had a
I mean, to stump you at the very beginning, but
because, yeah, we've been thinking about what we might find there. And it's just such a new object because we've never been to a type of object like this before. Personally, for me, it's hard to even predict. I'm ready to be excited and surprised by what we find.
So this is going to be quite repetitive because I'm just excited to see what it's going to be like. It's an object that no one has ever been to, this type of object no one has ever been to before. So I really, really expect it's going to just amaze us just like Pluto did.
Yeah, speaking for myself, I have to say I think these two women are very wise not to make predictions, because predictions in planetary science almost always end up upside down, and you only have to wait about 4 more days to really find out. But we've never been to anything not only so far from the sun, but it's so well preserved in this ultimate deep freeze of the Kuiper belt near absolute zero. So this is the time capsule that we've never seen before, that's going to take us back 4.5 billion years to the birth of the solar system. And I don't have any idea what it's going to look like. I can't wait to find out.
Right, when we're talking about first time exploration, I mean, this is pure exploration. You know, when you're looking at this type of thing, we've never seen a world like this, you know, and up close like that.
So I was going to say, it's going to be pretty cool because the public is going to see it at about the same time that we see it. So it'll be sharing this beauty of exploration and the wonder of exploration with everyone.
There are a couple questions on here that cover the same general theme. Those who have read stories about where we've mentioned something the size of a grain of rice for a spacecraft moving more than 30,000 miles an hour could be dangerous, if not fatal. And some of the work that went into making sure as best as we can that that doesn't happen. But there were some questions on here. What have we done to this point to make sure, at least to reduce as much risk as possible to the spacecraft flying through the unknown?
Well, you know, all exploration comes with some risk. And I think that's one of the great parts of what we do in space exploration is we take risks because it's worth the reward. But we spent 2 weeks on approach at a very carefully defined period in early December when we were close enough for our LORRI camera to be able to search for satellites, for rings and dust sheets and other things we might have to fly by or through. and the system looks clean as a whistle. And even since that hazard search that went on with a team of planetary astronomers scouring the data day after day for 2 weeks and seeing nothing, even after that, we've continued to look at the optical navigation data that's coming back to help us hit that aim point Alice talked about, and we still don't see anything.
Yeah.
So far, no satellites. So far, no rings. So far, no evidence of dust sheets. It's just Ultima. We'll see when we get closer if something pops up, but so far the coast looks clear.
There are some other questions on here, and I'm collecting because a lot of them are similar and they're really good. And there are some people, I guess, that even after this long journey and that we're a week away from Ultima, want to know what's next. What would New Horizons do? We have this flyby next week. We start getting data for this, which I think it'll take
20 months.
20 months to get all the data back from that.
Yeah.
But New Horizons looking ahead, what's beyond Ultima? What are the prospects for something beyond Ultima?
Well, Alice's spacecraft is very healthy. All of the primary systems are operating and all the backup systems are also available. And we have power and fuel to run this bird into the mid-2030s, maybe longer. By then, we'll be 3 times as far away as Pluto. And the Kuiper Belt is vast. We're not even halfway through it yet. We're going to be in the Kuiper Belt into the late 2020s. So what the science team and the mission team want to do after we get all the data back from Ultima is propose to NASA to explore the outer parts of the Kuiper Belt. And we have about as much fuel on board as it took to do Ultima. So we're hopeful we'll get one more flyby even farther from the sun, break our own record.
If there is another target out there for New Horizons to fly by, who would find it? How would it be Hubble? Would it be New Horizons itself? How would that go?
Yeah, we will use the biggest, and most capable tools that are around. We would probably start that search in 2021. If Hubble's still operating, and I hope it is, we're going to think about how Hubble can do it. If James Webb Space Telescope is up on orbit by then, we're going to think about that. But one of the most interesting things that we can do, I think, is look for it with the LORRI camera. We spotted Ultima from 200 million miles away almost. And we're able to actually look for things that you can't see even with the Hubble from our perch in the Kuiper Belt. And we might track it down ourselves with the New Horizons spacecraft. Nothing like that's ever been done before. It's almost a sci-fi concept.
It is. It was almost enough to be flying toward an object that wasn't even discovered when New Horizons launched, but then just add to that chapter as it happened.
Yeah. And this team's up for that.
Okay. So we're about out of time already. And this was so fast, and these questions that I know some more. So I used to say, keep them coming. It's going to be a busy week. We start with the programming next week, the flyby itself, again, coverage at 12:33 a.m. on January 1st. We have briefings leading up to that on December 31st. And then we follow up with science on January 2nd and 3rd. So stay tuned to NASA TV. Stay tuned to the New Horizons website at pluto.jhuapl.edu. Lots going on. Thank you for joining us today, and we can't wait for you to keep exploring with New Horizons.